All right, everybody. Mr. Sanford's here, back again after a short hiatus to talk about demography. We're going to look a little bit into demographics, the study of human population and the trends, as it relates specifically to the environment and some of the environmental issues that, well, some of those same ones that you guys put on those pieces of chart paper, what seems like about a decade ago. All right, here we go. So, uh, demography is a subfield of geography. And why is it part of geography? Well, it's because it's not just a look at population and population size, but it's particularly focused about spatial distribution of that population. So where do people live? What are the trends in terms of male, female, urban, rural, um, age classes, all of the above. So those people that study those factors are called demographers. And we're going to look at some of those stats. We're not going to get too in depth, but we need to look at some of them in order to understand what's happening within a population. And then with that, we can model what some outcomes might be in regards to the environment and resource management. So, I mean, you can do this on your own. Uh, if you want to think for a second and about what factors contribute to a population either increasing or decreasing, I'll give you a second to think about that. I mean, you can write them down, just think of them in your head. Um, Click on the link, and it will send you to a track from 1997 by a group that's before you guys were born. Uh, a group called the Jungle Brothers. This is from their album Raw Deluxe. It's entitled Brain. Oh, after the ad. After the ad. I'll let you guys listen to that on your own time. Okay, so another link for you to click on. This, uh, if we took all 7.5 or 7.6 billion people that live on planet Earth, but we turned that number into a percentage. So we made it into 100 people. If you click on this link, it will tell you, it'll give a portrait of what the world would look like if it only contained 100 people. Roughly half, even split, male, female. Uh, you would have roughly a quarter being children. And you can look at the breakdown in terms of ethnicity, place of origin, religion, languages spoken. Um, only 7 out of those 100 would have a degree or diploma from higher education, something after high school. You would have still, 9 people, so 9% of the entire globe that doesn't have clean, safe water to drink, which is what we were looking at before, either due to, physical or economic scarcity. So going back, what does that tell us about demographic patterns? What does that tell us about economic and social development? Because those factors are so crucial in not just defining and predicting environmental issues, but also in solving some of these environmental issues. So there's a National Geographic series that was produced looking at when the world tipped over that 7 billion mark. Uh, I'll let you click on it. It's only about a 3-minute clip. And after you click on it, I want you to answer, or as you watch, these 3 questions. So it looks at the world's population in 1800 and then how it advanced from 1800 to 1960. And furthermore, what the projected population will be by 2045. And after you've looked at it and noted those points, I want us to think about what this video reveals about the distribution of Earth's resources. So not just the resources themselves, but how they're distributed. So if we're to have 9 billion people, in the relatively near future, how do we distribute resources equitably to those 9 billion, particularly when those resources aren't equitably distributed right now? So, this brings us to this idea of carrying capacity. We talked about this a little bit when we looked at the biosphere. You've probably talked about it in science class, maybe even geography back in grade 9. And this idea of carrying capacity in any natural system looks at the maximum population size that a species can have within a particular area. So you could think of, goldfish in a pond. What's the maximum number of goldfish you could have before they run out of food or oxygen? You could think of this as, number of deer in Sifton Bog here in London. We had a problem not too long ago where there was an overpopulation of deer, and they were thinking of having a deer cull where they were going to actively get government officials in to kill some of the deer so that the other deer would have enough food to eat and space to roam. So, carrying capacity is that idea that there is a maximum after which you're going to run into limited resources. And because of that, there will necessarily be a dip in that population to match the resources that are available. And of course, for humans, it's a little more complex because we've developed systems and ways that we can increase our yield, for example, in crops. We can increase our supply of fresh water. We can increase our supply of things like oil that we use to power a lot of our daily life still. So it works a little bit differently than it might for those goldfish when we're talking about human beings. But a rough calculation says that if everyone in the world lived like us, the average Canadian, we would need almost 5 times the resources that currently exist on our planet. And of course, much of the world does not live like us. However, there is a large percentage that is starting to catch up. In particular, as we talked about before, places with massive populations like China and India, where we have, 1.3, 1.4 billion people in each of those countries, you're looking at a huge middle class that's starting to catch up and starting to use resources more similarly to the way that we do. So these are not problems that are just theoretical. These are problems we have to examine now in order to prepare for a future that is uncertain. So here are two projections of of ecological footprint. And remember, we did our water footprint not too long ago. An ecological footprint looks at more than just water or more than just your carbon output, like a carbon footprint does. It looks at your overall impact on the environment. And if you see those two lines, the red line and the orange line, they're diverging dependent on how we behave, dependent on our level of resource consumption, dependent on factors that are within our control. And you see that that red line is business as usual. So if we maintain the current trajectory that we're on, well, we're heading for a situation where our footprint as a globe will be huge and we'll need 3 times the resources we currently have, which is unsustainable. We also have a possibility where we recognize this. And in that recognition, we get a reduction in our overall ecological footprint because we start to consume less. We start to reuse more. We start to change from the consumerism that's rampant now and perhaps start producing food more locally. Uh, and a lot of these things are actually starting to be talked about with the current crisis we have with COVID-19. There's a recognition that these giant conglomerates, these international supply chains of food and goods, maybe aren't the best idea. And particularly during a global pandemic where borders are being shut and continue to be shut, we see that there are problems that we encounter. So it'll be interesting to see what happens at the tail end and after we get out of the situation that we're currently in, if some of these other ecological issues start to be addressed, um, because they're smacking us in the face a little bit. Okay, so that carrying capacity for us is not fixed. It's not fixed like the goldfish in the pond. There have been estimates that the carrying capacity of human beings on planet Earth could be as low as 2.2 billion, which seems not to be true because we have over 7 billion, 7.5 billion, though, of course, many people living in conditions that are far from ideal, all the way up to 40 billion. And those original estimates on the low side were at a time before we were able to innovate. So we went through the Green Revolution where we greatly increased the yield per square kilometer or hectare or acre so that we were able to grow a lot more food in the same amount of land. And that greatly increased the potential carrying capacity of our planet. We've also gone through innovations whereby it's now easier to access things like water. We can drill and find water. In some cases, we can even take the salt out. We can desalinate water that previously would not be drinkable. We've come up with ways to increase using using genetic methods. We can also increase our yield and grow more food, make more food than we could before. So it varies and it changes with time as our ability um, to generate more food, more resources changes as well. And of course, it also depends on our level of resource consumption. If we consume like Canadians or Americans, then of course that carrying capacity is going to be lower. If we choose a different path, then that carrying capacity can be higher. And if we look back historically, human beings have gone through a process whereby things started out very local, and that includes hunting and gathering. So societies that are hunters and gatherers, obviously by necessity, had to have very local sources, very local resources. So the carrying capacity was not so high. We then entered this agricultural revolution, spurred on by things like mass production of fertilizers, spurred on by mechanization, spurred on by the industrial revolution, really, where we were able to grow a lot more food in the same amount of land. Just talked about the industrial revolution there. So that idea of carrying capacity is absolutely critical in any biological system, and human beings are not a different. They're different in some ways. I shouldn't say they're not different, but human beings on planet Earth are a system, a natural biological system, much like you would have those deer in Sifton Bog. It's just more complicated because we have the means to adjust that carrying capacity much more so than, of course, those deer or those goldfish. So let's look at some stats that demographers use to analyze what's happening in a population, in a city, in a country, could be in the entire globe. And those are things like the birth rate. So the number of births per thousand people in a country, that's how you calculate it. Things like the death rate, which is the opposite, the number of deaths per thousand people in a country. Things like the infant mortality rate. So that's the number of children that pass away within the first year of life for every thousand births within a country. That's one of the keys to it, not just in Canada, but in any population. One of the keys to have that population, particularly the older generation, start to increase is to greatly reduce the infant mortality rate. And that's been achieved by and large with an improvement in healthcare and vaccination. And then we can look at the natural rate of increase. So the natural rate of increase basically says, what's your birth rate? What's your death rate? Let's figure out the difference between those two, and that will tell us what our natural rate of increase or potentially decrease is. So that does not account for immigration, people coming in, or emigration, people leaving a country. The population growth rate looks at though that natural rate of increase, but it also takes into account net migration. So by net migration, I mean how many people are coming in and how many people are leaving. Obviously, right now, in a situation where a lot of borders are shut, not a lot of migration is occurring. But before our current situation and after that, it will resume. There will be people that leave Canada to go other places, and there'll be people that want to come into Canada from other places for many reasons. And those are called push and pull factors. So a push factor is something that makes an individual or a family leave a place. A pull factor is something that draws in an individual or a family from another place. So you can imagine pull factors to Canada being things like our healthcare system, things like education, things like job opportunities, things like public safety, having a safe place to live. Whereas things pushing you out could be higher salaries in another country for that same job, or perhaps educational opportunities where a country specializes in a certain field or a certain industry. So you might go there because opportunities are better. So that population growth rate looks at natural increase plus net migration. And if you look at Canada, Canada's population growth rate is a little over 1%. India's about 1.3%. Japan's is actually negative. Now, if we looked at just the natural increase in Canada, we actually do not, you need a, uh, with just natural increase, births minus deaths, we do not currently in Canada have enough people to sustain our population. So for every female to have children, you need a little over 2.1 as a rate. So 2.1 kids. I know you can't have zero point 0.1 of a kid. It's an average, but you need a little over two to maintain that population, knowing that it takes two people to have a child, and there'll be a percentage of people that don't have any children at all. So you need to be a little higher than two. And we're at about 1.6 in Canada, which means that we currently do not have enough people just by natural birth to sustain our population. The problems in Canada are also compounded by the fact that we're a relatively old population, which we'll talk about after. So Canada has a lot of old people that are retirement age, and those people, though they've contributed to the economy for a long time, since they were in their teens all the way through to age 60 or 65, the average lifespan now in Canada is all the way till 82, 81 or 82 years old. So you're looking at 15 plus years after retirement that people on average are living for. And that's a problem for our economy. It means that we'll still be paying, Mr. Sanford will be paying Mr. Pettit for many, many years after he retires. Because hopefully, Mr. Pettit's my friend. I hope he lives a long time after retirement, but he will no longer be contributing in any monetary way because he will be drawing from his pension that younger people will be paying into. Well, once you get to a certain number of people that are in that area where they're in retirement drawing pensions, those pension plans get to be in trouble if you don't have enough young people to continue paying into them, which is why immigration is absolutely key to economic success in Canada. We need skilled immigrants to come in, or else we're not going to have enough doctors and engineers and all the other fields that we need to keep our economy running. So Canada is absolutely reliant on immigration to ensure that our economic success continues. I think I talked about all these. Immigration are people coming in, emigration are people leaving, net migration being the difference between those two. So we can also turn those into rates. Again, that's important for doing these calculations. We have to turn these things into numbers so that we can make informed policy decisions. If we don't have good data, if we don't have good information, it's tough to make good decisions. And you're seeing that in real time, interestingly, with the coronavirus. There are a lot of sources of information, and it's very, very important to make decisions that are informed by the data, meaning it's very important that you have good data to make those decisions. Now, whether or not people follow the recommendation based on those, that's another story. Okay, I mentioned in Canada that we have an aging population. And that means, so they define dependents as people that are under 15 and people that are over 65, meaning that you are dependent on the rest of society because you are no longer monetarily contributing to, in a large way, to the tax base. You're still paying taxes, when, sales tax when you buy stuff, but as since you're no longer actively working when you're under 15 or over 65, you're now drawing money from the economy. And if you have too many people that are under 15 or you have too many people that are over 65, your economy is in trouble. So as I said, that's why Canada so needs immigrants to come in to fill those jobs that are vacated, um, especially those highly skilled jobs that are vacated by people that are retiring. And our population's getting older. More people are retiring than are coming in from that under 15 class. So essential. So that dependency load is defined as those number of people that you have in your population that are under 15 or over 65. In a lot of developing countries, they have the opposite problem, not too many old, but too many young. And again, society, those people, those 15 to 65-year-olds are the ones that will support those that are under 15 or over 65. And that's how you do that calculation. So, what I'd like you to do now is to answer some questions, uh, some of which that you might have thought about when you're doing some brainstorming, some of which you might have to think about a little right now before you answer these. I've put them on a Google Doc that I'll put in the classroom. So, first off is a look at population density. So, population density is the number of people per unit area, square kilometer, hectare, acre, whatever you want to use. And there are pros and cons to high density. I want you to think about uh, how some cons are obvious, but I want you to think about how high population density, like we have in big cities and even mid-sized cities in some areas in London, even though we're pretty spread out, how is that beneficial for the environment? And I'll give you one example and I'll let you think of some others. For example, before obviously the pandemic hit, there's a big push to have an increase in public transport. And it's very hard to have public transportation be effective when you're spread out, sprawled out with low density, much more effective when you have higher densities. The second question I want you to look at is carrying capacity, that concept that we talked about earlier. So, the carrying capacity of people on our planet actually continues to go up. As I said early on, people thought it would be maybe 2 billion. Then they said, okay, well, no more than 5 billion. Then we passed 6 and 7 billion. And we don't really know. I can't bring it down to one number because of those previous factors that I talked about. But I want you to examine why our carrying capacity continues to increase. And maybe you could even look up what some estimates are for where we will be, maybe not this year, but within the next 10 or 15 years. And lastly, there's been a major shift from rural to urban in Canada for sure since the turn of the last century, where most people in Canada live in cities, by and large, live in cities. And I want you to think about how that affects the environment, both positively and negatively. That massive shift away from rural life into urban life. As I said, I'll put those in a Google Doc on the classroom, and you could submit your answers through there. Um, I'll just mention one last thing. I mentioned it in the weekly update, but if you haven't already, please take a look at the revised ISP document that I posted, same components. So you still have the annotated bibliography, you still have the Esri story map, and you still have the case study. I've gotten back to everyone that submitted an ISP proposal, giving you some advice on whether you should narrow the scope for the case study and then examine it more broadly for the story map. But please check that revised document. And as always, if you have any questions, post them either in the comment section on the classroom or send me an email. And hopefully you get out for the rest of the week and enjoy. Going to be 20 degrees and sunny. All right, that's it for me. Have yourselves a good day. And if, well, whoever would like to meet, I'll see you guys on Friday. Bye now.